So today we're going to go over a few things. One of them will be the announcement and just discussing the announcement that was sent out yesterday, as well as um, some of the points that were discussed in the announcement, what they mean. And then after that, we'll just be wrapping up Friday's lecture. Friday, we almost finished. We made the orchard example. It's the same one that's referenced in the announcement. We built part of the back end. We just have to finish making that back end, like adding security and login. So there's that. So yeah, we can go over the announcement. I'm just going to share my screen. And basically, anyone has any questions, like feel free to raise your hand and we can take a look at those as well. Okay. So I will share my screen. So if everyone can see that, let me know. And so this is the Project Week announcement. So this announcement essentially pertains to the next 2 weeks. Basically, the next 2 weeks are entirely going to be for working on projects. So today's lecture is still happening, of course. It'll be really short. But yeah, so we'll have 2 lab times per day, 8 a.m. to 12, and then 1 to 5, and then 7 to 8 will still be office hours. So these are just dedicated times for you to ask questions and get help on your project. We'll make sure we'll always have an instructor here. And if need be, we will have more than one instructor as well. So here are some tips you may find helpful when coding. I guess we'll first go over these. So we would strongly recommend each new feature you work on be in a separate branch. So let's say you're working on React Project 3, and the first bit is just pure React. That's good, or React Router, right? You're setting up initially things, you're making use state and these sorts of things. That can be like you do some portion in your main branch. Let's say you just do React. Then now you want to add React Router. Okay, so now you check out a branch, you work on React Router there, you make sure it's working, there are no bugs, you merge that back into main. Okay, now you want to add Redux. So you check out another branch, Redux from main, you add it there, right? And then you merge that back into main. So the idea is just you always have a version of your code working on some other branch, probably your main branch. And this is just, it's a good practice. You just have a working version of your code, but you can also compare and see like, okay, if an error was made, where was it made, right? So whenever there are breaking changes, like significant changes that are going to happen to your application, that's a good idea. We'd also strongly recommend only working on necessary features required. So necessary features, if we go into, let's say, a certificate project 3, let's say someone wants to do, okay, sure, quote manager. So, being able to have multiple quote lists be listed, creating, updating, and deleting a quotes list. So update refers to updating quotes inside of them or maybe changing the name. And then add, delete, and update quotes in a quotes list, right? Displaying them, just seeing the quotes lists, and then also the quotes within, and saving to JSON and loading from JSON. That's it. So those are not that many features that are required. And actually, there's no search, there's no filter, right? There's none of that. So, we recommend when you're working on this, just to first implement these core features. Even like Certificate Project 3, you're doing that, just do those. And then once you're ready for 4, actually do 4. And then if you want to add these features into your front end, when 4 is done, go back to like 3 and just add those features. And basically in the client, you add those features in once the server is done. Because the thing is, in Certificate Project 4, setting up the server and the database and models, none of that will actually, like front-end features like building search and filter and some of these other more like quality of life things in the application, those won't change the underlying data structure. Or if they do change it slightly, you can sort of work around it and you can anticipate those changes. But you can still complete the certificate project 4 before completing those extra features that we are not actually grading your project on. So that's a recommendation that we have as well. Does anyone have any questions before we continue? We'll talk about some of these other points as well. Okay. Yeah. So it's just like, core features done for 3, then you do them, then you basically do 4, which is the back end. And then when that's done, then you can always, if there's time, you can always go back and add those extra features that you wanted in the front end. Okay, perfect. So certificate project 4, so the slides for that are available now. Let me actually show you. And then we even added a bit in project planning. So I'll first go through some of these slides. Actually, before I go this, so what we've done is, so we noticed, there are a lot of new concepts being taught, or a few new concepts, but the bigger thing is that this is the first time we've seen React Router and Redux together being used with the server in the backend. So it's quite complicated, let's say. So what we've opted to do is we have an Orchard example. So, the one that we started on Friday, and we're finishing today, which is just the backend setup. But basically, this can be a reference for a working implementation that combines React Router with Redux, server endpoints, and database as well, the MongoDB. So our intention is for you to deeply understand it as a working example, almost like reading documentation and taking notes and noticing, how data flow is working. We don't recommend just copying the code because you might be able to just copy code in some places because, again, projects that use similar tech stacks, code can be copied, but we wouldn't recommend just copying code because if you do that, you will actually find a lot of difficulty in completing your certification project 4, both the implementation, but also during the oral exam, answering questions regarding how things were built or, even making a small change in a feature. Because, the code, yes, it is a good reference example in terms of the same tech stack being used, and perhaps the level of difficulty we might expect, but it's not it's still not your project, right? It's not the exact same data, and it is a bit different how things are happening. So there is that. One thing that we opted to do, so I'll actually show the project here. So these were the instructions and their starter files. So the thing is, this starter file is just the server. So what'll actually end up happening is you're done cert project 3, right? And then you have all your files on GitHub. What you'll actually do is we would recommend you make a new repo called cert project 4. In this, you have a client directory where basically this content, you copy it to here, and then you have a server directory. Now, this server directory is what we provide from the starter files. It's just that server directory. And the idea is that essentially we are building a server for our client from project 3. So that's why we recommend finishing project 3 first and then moving on to that. We made sure, so I'll just clear that. We made sure that in the instructions, we were very clear about that approach. Ooh, is it? Maybe I'll just download it. Okay. Let me find it. There we go. Okay, so this was, I don't know why that's not loading. So this was basically, it's this. So the idea is, yeah, so this is just reiterating how to set it up initially. What we wanted to do was we wanted to provide kind of like the mini projects. No, so not cloning certificate 3 repo. You make a new repository you copy the files inside of it because you want these to be completely separate. So there are more instructions. I think we give more specific instructions here. So a new repository, and then the contents get copied into client. And what we've opted to do actually is to, exactly, yeah. So just copying and pasting the files from local repo, exactly. So what we've opted to do actually is, kind of like the mini project, there were a series of steps that you guys went through. We wanted to provide a similar approach. Now, your starting point is a bit different because we already have a front end. It's just not, there's no back end with it, and it's not connected to it. So, the first thing is understanding the Orchard example, which Friday and today's lecture will complete at least the back end part of it. The next part, so setting up MongoDB, that's something you'll do first. Setting up the Express server, then you'll add security and login. So the idea is these 3 steps will basically finish the back end, essentially, for the data portion of your project. So what that means is that when by the time you're finished step 4, all the backend features basically that's required to support, your application are done. So a person logs in, let's say you're doing the task list, right? So all the endpoints for tasks, the endpoint for the lists, right? Logging in, getting your task lists, the tasks themselves, creating a task list, creating tasks, editing, update, right? All of that is done in the back end at least. So you could use, let's say, Thunder Client to send requests and to actually see these things change. You'll see the request being received on your server terminal, but also seeing changes in your MongoDB database as well that reflect that. So that will be completed. The next step, though, will then be connecting the front end that you essentially copied over from project certification 3 and the back end you just made. So that is step 5. That's connecting those two, essentially, and making sure that those are working as expected. Then front-end testing. And again, front-end testing doesn't need to be that complicated. We just want like one test, and it doesn't even need to be like a button click. It can just be, does this render appropriately? That's it. Just, one thing render appropriately, just to have it there. The backend tests with Supertest are also fairly straightforward. We just opted for 6 tests, so 2 for each. You'll find you'll have 3 resources at the end, and it'll be 2 for each. So a get and a get by ID. Again, very straightforward tests. You're just grabbing stuff from the database, okay? And then, of course, deployment, which is what you've seen before. It's essentially the same as mini project part, I believe, part 5. And each step of the way, so we have some details about how to proceed. So again, the next few slides just go over how to do each of these steps in some amount of detail. In the slides, what's being used is that Orchard example as a reference for like how things are done. And you'll find it, if you understand that Orchard example well, you'll find it actually very helpful to completing things. So there is that. Does anyone have any questions? There's a few more bits to go to refer to, but we're almost done. Okay, perfect. So, right, so now certification, the project planning page, right? So, project planning 3 is a lot more straightforward because, again, it's just front end, and really it was just thinking about a UI tree and like data flow and things like that. Project 4 is actually more difficult in terms of the planning part. Now, it's similar in the sense that kind of like it's a wireframe, but actually we call it, or at least I've called it a something called like user navigation diagram. Now, because I mean, imagine when you have this application on localhost, user is just sort of navigating through it, all is well. The site responds dynamically to what the user does, but the response now is a bit more complicated because your state is going to be in Redux Store, and you're also interacting with endpoints when you do things, right? Like when you log in, a login request is going to be sent to the endpoint with users, right? And it's going to be like checking, okay, well, you have a login endpoint, and so it's different, but it checks the same collection of users, and it's like, okay, is this person really sending me correct information? If they are, then I'm going to return the response back, right? But the thing is, you actually have a Redux store now. So you have in the store, you have a slice to store um, the whoever is logged in. So there are a few moving pieces, right? You have Redux store, you have endpoints that are being interacted with in the server, and then once you interact with an endpoint in the server, you're really just interacting with the Mongoose model, basically the collection. So it's almost like three things are interacting together and sending data back. Store. It's almost like you're sending something to happen. Well, this will be a hint, but you'll also see it in the orchard example. It's almost like when you want something to happen, you have to update the database, but you also have to update the store, right? So and sometimes even responses from the database get sent to the store to update it. So that's a big hint, but you will see that in the orchard example. So in planning project 4, again, we have this slide here, and what the slide is essentially, and I'll need to download it again. What this slide is turning it turns the orchard example into a visual. And now the code for that orchard is provided, right? So this, it seems, okay, it might seem a bit much, but so here's the thing. These are like a few things that are happening, okay? And these are endpoints, and then these are collections. So this is like MongoDB collections here. These are our endpoints, and this is what is happening here. So this is like front end, what's happening. So the following, so orchard example, we have the code to explain this, but what's happening is when a user logs in, they create a basket and then they go to the basket to add a fruit. So like what are the moving pieces? Thinking about these ahead of time. So once you set up essentially your back end, before you go to the front end part and like connect those two, thinking about this ahead of time can save a lot of time because then like if you draw something like this for even just one thing, which is could be a user logs in and they create a new quotes list, and then what they do is they want to add a quote to it, let's say, right? That could essentially be the feature that you want to visualize. And you might only need to do it for one of them, but just to show that, okay, these are the interactions that are happening. So I need to keep in my mind when I want to, let's say, add deletion of something, these are the things I need to do, right? So in this case, Redux store and front end, endpoints in the server, and collections are all interacting. You might not need something in this detail, but you should be aware of these moving parts and how they interact, and it will go a long way towards making the implementation much easier. So notice when we log in, we click login, we send a login request to login. Now the response comes back. Then we make sure to dispatch the response to update the person in the person slice in the Redux store. So that's what this one means. And then again, these few, it's like here. So here we actually click a basket. So we use the person ID to refetch the person. So this is actually before we click a basket. When person updates, there's a few things that are happening here. So I think these I'll leave to you to go over in more detail because it will require looking at that orchard example. So actually, let's go back to here. So does anyone have any questions so far? You probably won't need something like this detail, but the thing is, and you won't need to make it for every of your features. You can just plan like one thing that happens, like let's say this, user logs in, creates a quotes list, adds a quote to it, right? That is like a starting point. And you'll have something like this. I would probably pick something like that, something that requires initialization of, fetching things from the database. But basically, once that's done, then you have a working picture of like these three things interacting together. And then you can just keep that in your mind whenever you just want to confirm, okay, am I correctly handling, let's say, updating a quote or deleting a quote from a quotes list or just deleting a quotes list in general? Is that being correctly handled? So those are all things that should be thought about. Okay. And again, the orchard example, if you look at that, you will see that in a bit more detail. Because that code is there, it is implemented. So, okay, so just want to talk about React Router usage. So we mentioned something called loaders in certification project 3. Okay. So there's a question about, is it this part or this part? Why do we need to add the route in the project for cert 3? I don't quite understand the question. So this is for project 4, where the routes, endpoints, server, right, database, these are all required because it is the backend. Oh, okay, I see. Right. So actually React Router is needed for a cert 3. It's just your state, you can still have React Router with a purely front-end project. You don't need to have a backend to have React Router work. Router just lets you have basically your URL will change, let's say. So here's actually how it would be different. So the only thing that differs is where we get our state from. So if we have a backend, we probably have some well, with Redux, you will have a use effect, but maybe the first thing that happens is we have something function that runs, it gets things from the database, and then it dispatches that to our slice, which updates the store. And essentially then what happens is that, let's say we have each of these, let's say it's a quotes project. So each of these quote lists has an ID. And when we want someone, so we have some like, when that renders, we have like a list of basically the names of these quote lists. And when you click one, you render the quotes list then, and the URL of the page changes to have the ID of the quotes list as well. So that's the backend version. If it's purely front end, what will actually happen is you will still need an ID in your like representation of a quotes list. And essentially that ID will, when you click that, the route will change and that ID is added. So you can still you'll actually have to use React Router for Cert 3. What changes though is just where we're getting our data from. Is it in the database or are we just getting it directly from our use state? Sort of database / Redux store, yeah, or use state. But we do, again, the Orchard example, there is a React router in that. So you can take a look at that. Again, it's like documentation to see, okay, what is correct usage of React router? That, although I will say that that example there in the Orchard the data is coming from the backend, but the general structure of what the React router and like the links and that, it looks similar. And I think even in the starter code we gave you, we did set up a few links already. Yeah. Okay. Right. So we mentioned something called loaders. Don't worry about those. That's not necessary. We actually recommend not using loaders. Just keep it as simple as possible in terms of router. We strongly recommend, using the same approach that was given in the starter files. You can also see, so we also have this example as a reference here. So this was at this point, and so here's the thing, actually getting familiarity with this example will be really helpful because notice we have basically different branches that correspond to this application at different point in time. So here, let's say for React Router, Redux has not been added yet. This is just pure React Router. And notice, because notice that we are using state here. So this is before, like, when we developed this, we developed it iteratively. We first just got React Router working, then we added Redux, then we added Redux Thunk. So I'll discuss that shortly. And then we added, and then we just continued from there. So we have like almost like a life cycle. This is a good reference for that, in terms of looking at router. And actually, when it comes to Redux Thunk, again, the usage of Redux Thunk. So we mentioned that also in certification 3, its usage is not required. What Redux Thunk does is it lets us, so you guys remember those like services functions that you would import into your components? Like you would make a person services or a fruit services, or I think note services, right? And then in those files, you would essentially have like your Axios requests sent to the backend that do async things, right? And you call those in your components whenever you want to get something or make a change or something like that, right? So when you have Redux, so the thing is that it is ideal before you have Redux, when your state exists inside of that component and you are making changes there. That's perfect. But when you have Redux, the logic is that your state now exists in your reducer. So the idea is that Thunk lets us move those services out of the component. Now they get imported inside of that reducer. And we export functions in the reducer that actually can asynchronously handle someone trying to do something that is like requires a promise, like let's say logging in, and then dispatch an action that updates the slice. Again, we have that in code, but the thing is, we actually don't require it because it doesn't change. It doesn't change the understanding of Redux. It's just like moving something somewhere else, essentially. Functions that modify state should be where the state exists logically. So it just involves making that happen, but it's not required. So actually, in light of that, again, you might have noticed that we have a Redux branch of our code, and we have a Redux Thunk branch of our code. So again, that is more documentation there for you to understand like what it would look like with Redux and what it would look like with Redux Thunk if you want. But you don't need to actually even do any Redux Thunk. You can just sort of stop at Redux and have it there. It wouldn't be too different. And again, like, treat the Orchard example as documentation to read and to understand that data flow, not to just copy sort of to make your project backend around. That will not go well. Okay. So we've also released Mini Project Part 6. It's purely optional. It's actually not required to for the certificate 4 or any of the certificates really. It's just an exercise. So, basic security and login is being added to the currency converter app. It is potential practice if you have time. Like personally, I wouldn't recommend doing it. I would recommend just focusing on certification project 3 and also all of certification project 4 up until the point where you might need login security. But even then, um, it's up to you. If there's time, you do have like Friday's lecture and today's lecture that we are essentially been building. Today we're going to build the logins and security for that Orchard example. But the example that was referenced here that we sort of think we have linked it here is, yeah, this one here. It's linked in a few places. It's also linked in these slides, right? Like this example here, it has login and security set up as well. So that's also it's sort of documentation or reference how that is working. All right, does anyone have any questions about that or anything that was discussed before we head on over into setting up login and security?
Just to clarify, so for in certification 3, do we have to, is the about and the contact form also part of it?
No, you can essentially leave. I just sort of added those just so it would be a bit easier to put the React router there. But that's not actually, I mean, it would be really short. Like contact, you can just put your name or something, and the about can just describe your application. Very short, if you want to put that there. But you don't need to implement a page that has a bunch of things. I think eventually what you can, yeah, I think I'll just say that eventually you can even just remove those and just have like directly have your app with your routes inside of it, right? So you can actually just do that. I just put it there just to show an example of routes that you could look at, but this was before the Orchard example was available and that we had thought of doing that as a better documentation for you guys. So yeah. So you can even just like remove that and just have inside your app, you can have the routes here. But again, those routes being rendered is a bit dynamic, right? It does depend on there being data in your state. And we do have, Orchard example is a really good reference to understand as you're planning your certificate project 3 and like slowly working through it. Absolutely. Um, yep. Okay. All right. So let's actually, okay. So I see a question here. I'll take this question and then we should take like a 5-minute break before we start off on the next lecture. So for certificate project, is it possible to extend the time? Is it possible that time is short? For sure, yeah. So if there are extenuating circumstances for this bit, do email us, the support team, and let us know. But 2 weeks is, I would say, given the so we have provided a full timeline of how to do it, and we do have like direct help given as well over the next 2 weeks. So 2 weeks is enough time to complete certificate project 4. If you properly uh, sort of partition tasks and plan and things like that, 2 weeks is a lot of time to complete it. Um, Yeah, once you actually get started, you'll notice that, really, and it's not the hardest part is starting and planning, but the actual implementation of code is pretty quick. All right, so I'm just going to pause the recording, and we'll be back in a few minutes. So today's lecture, we're essentially going to just pick up on where we left off. So we were setting up the back end of that orchard. So we have the baskets, we have the people. Well, we don't have people yet. We just have baskets and fruit. And we're going to set up the people endpoint for login and also for user creation. And yeah, so this is where we left off. And let's actually go over some examples, or I guess we'll go over what we have just to review from last week. So we have two models, config. I guess the main, like the crux of things happening is in this basket and in this fruit. So remember how, because there is ownership and what we have references across collections. That's like the formal term for, one model having a reference to another model, a basket owning many fruit, let's say. And a fruit can only be owned by one basket. So there's a one to many, but one to many from basket to fruit, one to one from fruit back to basket. So that's actually quite important. That is there. People will not share their fruit. So you might notice here, let's say for instance, when you want to delete a basket, this is just purely back-end side, but this is important, right? This needs to be correct before we even think about building, sort of connecting this to a front end and doing all that. So that's your hint there for the project as well. You can notice here that when we create when we want to delete a basket, we actually need to first remove all the fruits inside of that. So, we have this particular function here. What this does is it just, this is grabbing the basket with an await because it takes time. So we use the ID that we grab from someone sending the request. It's in the URL, so it's a request parameter. We grab the fruits and then we just map over them and convert those IDs, which are object IDs, into correct string IDs, okay? Once we have that, then we essentially, what we can do is we can map over this array. We can make another array composed of, when you map over this, essentially every ID is turned into a request to the fruit collection to find that by ID and delete it, which is actually what this is doing, right? So this returns interesting. It looks like it returns a query, but the point is, each of these has to be executed, and they're also asynchronous. So, an easy way to do this is to just use this thing promise.all. And what that does is it takes an array of requests that return promises, okay? Or are asynchronous requests. So we have an array of these requests because remember, each ID is turned into this sort of request to delete it. And then we pass that array into promise.all. So that's going to handle actually performing the fruit deletions. We don't need to worry about, manually deleting each fruit or something like that, right? Then we remove the basket. Again, find by ID and delete on basket, and then we return the response. So we did test this, and fortunately, everything was working as intended. So let me actually, let's run this server, cd server, npm run dev, and where was this? Okay, so this was in the user example. So let's just, let's go to our MongoDB and sign in. So you actually have to click database, browse collections, and here you can see your collection. It's a much nicer, UI than PG Admin, that's for sure. So we have one basket and it has one fruit inside of it. And our basket's name is basket and it has a mango. So that's left over from Friday. So we have that. That's good. And of course, if you recall, we did also test deleting baskets and adding baskets. I think I have the history here. Yeah. So these are all the requests we went through, or at least I think these few. Yeah, so we deleted baskets. Looks like we made baskets. Everything was working, so that's good. And yeah, so for fruits as well, when you create a fruit, it looks like we also need to pass in the ID of the basket. So notice that the fruit is in the request body, but the basket ID is passed in the URL, right? So, and then we have to actually go through. We have to first create the fruit, and then we have to save the fruit, and then that saved fruit gets added to the basket in this particular way. So we actually had to get the basket up here as well. And then we have to, again, we have to wait, we have to save this basket, and then that's good. Deletion of a fruit is similar. We actually, we grab the basket it belongs to, we delete the fruit, and then we actually do a filter on the fruits inside the basket. And I guess what this is doing is that it's checking each ID in that basket, like in the fruits inside the basket, and it's just saying, okay, convert it to JSON, and then that does not equal fruit ID. So the filter is basically going to return false when the IDs match, when it is on the fruit that we want to remove. So then it's actually, that will not pass the filter. So we set the basket.fruits to the result of that filter. It removes that particular fruit's ID, and then we save that. Okay. Does anyone have any other questions about the state of this application at this point in time with just basket and fruit? Okay, sounds good. So it's pretty straightforward. It's just the more complex part is these in these endpoints, it's actually sometimes multiple collections are actually being referenced because of the references across collections concept. Okay, so now we're going to think about user or person. In this case, it's a person. And how does that change things? So I just have, we will go here. Oops. Okay. This is a slideshow. Okay. So now we're going to think about login security. What changes do we need to make in the database to support this? So you'll often find that when you're developing your own application as well, what precedes server endpoints is actually database changes or modifications, because the server, there is a database behind this. And so even like in your own development, when you're doing this, you can do it in steps. You add these two models that are closely connected. Let's say if I was developing this basket, I first have basket and fruit. I first did that, and then I added login and security on top of that, but I had to make changes throughout my application to get that to work. So I even did it on a separate branch. So if you look at the Orchard example, I believe the server and database setup is one branch, and then login and security is another branch where I had to add that in. So anyway, let's imagine an orchard. So now we have person, basket, and fruit. We can have any number of people, each of which owns any number of baskets, each of which can own any number of fruit. So And again, although caveat, a person can own many baskets, but a basket can only be owned by one person. So essentially, it's almost like the relationship between basket and fruit is the same as the relationship between person and basket. So you might already be able to anticipate some of the changes that we need to make in the baskets router to make it work now. It might even be that it's some of these changes are a lot like what we're doing in fruit. Okay. So this is in the last lecture, there was this pattern. This is that pattern of changes that I talked about. There's a consistent way that these endpoints look, or that these, that these endpoints look like when they have these sort of references. So we want to be able to reflect the above relationship. So let's extend what we saw on the previous slide. So we first had basket to fruit, one to many, right? And there's also and I will just actually do this here just for this sake of having it. There's also a one-to-one going back that way, okay? So we have that. Now we have person to basket. And again, a person can own many baskets. So notice they even have this baskets here. So that is also a one to many. And then going back is a one to one. Let's now think about some changes that might happen. So the baskets inside of person will store object ID of all basket that are owned by the person. Object ID, again, is just how MongoDB distinguishes these documents, okay? I'm just going to clear those annotations. And what I'm going to do now, let's actually do need my presenter notes. Okay. Let's just skip through some of that. Okay. So now, before we actually implement those changes, we're going to first just talk about them. So this is a major change, expanding the database model to now include a person. And I also mentioned it here that no basket can exist that is not owned by a person. Okay, so that actually makes things a bit simpler. And as far as we're concerned with, when it comes to your own certification projects, eventually when you add, it makes sense, let's say for quizzes, no question can exist that's not owned by a quiz, right? Like that sort of, that analogy should apply. Or when you eventually add users, no quiz can exist without being owned by a user. So, and that should extend to task list. It should extend to the quotes list as well, and like their relationships with their quotes and with the user as well, right? So, yeah. So what stays the same and what changes? Does anyone have any, feel free to type in the chat or unmute and we can just talk about it. Like, what endpoints do you think might stay the same and which ones do you think might change now that we've added a person owning a basket? So feel free to comment on that. I'll give a hint. So we do need to have a login and a router and a people router. So we'll add a button new endpoints just to handle the new resource person. So that, that is, although that's to be expected. I guess we'll also give a hint that, yeah, so here's a question. With the change we saw in the earlier slide, do any endpoints on the fruit router change? So now that you have people, do we have to worry about fruit? Like, let's say if I want to create a fruit, does anything need to change? Originally, I'm sending in the fruit and I'm sending in the fruit that I want to create, the request body, and I'm sending in the basket ID. Does anything else need to change inside of fruit, given what we've talked about? Okay, so person ID, okay, that's a good, well, it's a good question, but, all right. Fruit is owned by baskets, and baskets are owned, but baskets are owned by people. So just in the fruit endpoint, we don't need the person ID. We will need it, but we'll need it in a different endpoint. Because a fruit, remember the model that I showed here, this model is not going to change. This is not going to change. These model. And actually, this model gives you a hint of what changes. Because you'll notice there's no place to have a person ID in the fruit or the basket, actually. Well, in the model, but we will need to send it. Okay. So in fruit, we don't need, it's a trick question. They do not. But why don't they, right? So here's the hint. So the thing is, inside of a basket, maybe I can like draw a basket. Here is a basket, and here is a fruit. So there are two fruits. Let's just do a few fruits. This person was picking fruits. 1, 2, 3, 4, 5. So we have 5 fruits in this basket. Right. And so the idea is that the IDs of these fruits, they will exist inside fruits inside of basket. But the idea is that the person here who has baskets, this ID will reference this basket. But that's it. So the fruit itself, exactly. Anybody can add a fruit in the basket. It's not referencing anything initially. That's correct. So when you add a fruit to a basket, all you need is the basket ID and like particular details about the fruit. You don't actually need to know whose basket's being added to, because the thing is, that basket had to exist in the first place, and it has to actually belong to a person when it's created. So that's a hint for actually what is changing. But as far as fruits are concerned, nothing new is happening. And you can even think about it like this is our, let's just do B and F for basket and fruit. This relationship is already sort of in the endpoints. What changes is when I add a person. So this is a new endpoint. The basket, from the perspective of the basket, it is actually has a new something pointing to it. So it has to change. Fruit does not. Fruit, as far as fruits, from fruit's perspective, looking outwards, it's looking out and it's saying, okay, person was added, but they're not actually, there's nothing like that is not happening. It's just only basket is changing. So the fruit doesn't need to change anything in its endpoints. It's exactly as it should be, because from its perspective, it's not getting a new reference arrow to itself. Only basket is. So basket needs to change, and of course the person is changing because it doesn't exist at first. So we have to create that. Okay, so I hope that clarifies this idea of being able to identify what changes and what stays the same. Okay, so I'm just going to clear those drawings and let us continue. So how might basket change? So basket is going to change now. Both, so I will say that get and get by ID do not change at all. But maybe can I like undo? Right, so given these changes that we've drawn up here, now basket has to exist sort of in a person. A person has to own that basket, right? So how might post change? So hint, no basket can exist that is not owned by a person. So our post request will change. We will need that person ID. So that's actually pretty significant. How might delete change? When we remove a basket, what happens to the person? So that also changes. When you delete a basket, the person also should be updated. their baskets, right? So they don't actually have that basket. And I can give a hint that this looks a lot like fruit now, right? Because fruit also, the creation of a fruit, we create the fruit, but we also add that fruit to the fruits inside the basket that it belongs to, right? So just to signify that that ownership is there of that fruit. And when we delete it, we do a similar thing. We do the opposite. We essentially remove the fruit ID from the fruits inside the basket. It's exactly the same thing that's going to happen now. Exactly. The basket's removed from the person. The basket is added to the person in the post. It's removed in the delete. So it's very similar approach. And this is this idea of like there's a pattern, right? There's a way endpoints, you know, when I just this, when something is just like that, there's a way the endpoints look. When something is like that, there's a way like a person, there's a way those endpoints will look. Or previously, this like before we added person, this is basket. It just had a reference going out, right? So there's a way endpoints will look in that instance. There's a way endpoints will look in this instance, and there's a way basket endpoints will look like this when there's something referring to them, and they're also referring to something else. So these are like three cases. And they'll sort of repeat themselves regardless of the circumstance. Like if a model is used like this, there's a sort of pattern to how the endpoints will change and what they will look like. Okay, and we will see that in the code. Like for instance, fruit, get and get by ID don't change. Post and delete change. And here you might notice nothing changes except delete, because post is just a default. Like you don't need to like add this to anything, right? Whereas here, post and delete change. So actually it's almost like the fact that it is being referenced by something here involves that, right? The post and delete changing. Now this is just delete, but you'll notice actually that the delete of the basket will be a little bit more complicated, because not only do we need to, because it's owned by something else, we also have to update the person on top of deleting the fruits. So there's a few things happening, but we'll get to all of these. I'm just going to clear those now and let us continue. So people router, yeah, get by ID and post, as we mentioned, those don't change. Delete changes. So here's a hint: when a person is removed, what happens to their baskets? What about their fruits? So the person delete endpoint is going to be pretty complicated because there's a bunch of things happening. We need to delete all the fruits. Then we need to delete the baskets. Then we need to delete the actual person. So there's like 3 deletions in one, essentially. Okay. So with that discussed, let's actually make these changes to accommodate login and security. So we're going to exit from here, and we'll just have this open here. We can always refer back to it. Okay, so let's make these changes. So first things first, we're going to make the models. Let's close these. We're going to make a model to represent our person, okay? So you might notice that's going to look a lot like, it's going to look a lot like basket, because it's just going to reference the basket. Let's do this actually. So what I'm going to do, I'm just going to make this, and I think we can take another 5-minute break once I just get this set up. We're going to have the person schema. Mongoose.schema. Name is string. And again, we're actually going to have a password hash. So we'll need to hash things. When you create a person, you'll need to hash things because we don't want the password to be directly stored. So there is that. Notice that this basket, it's looking a lot like fruits here, right? And it's actually going to be essentially the same thing. Type, am I missing something? I don't think so. Mongoose.schema types of object ID. Something is missing. Oh, this should be. That first one should be an array. So this is just telling us that it's going to store object IDs. And then each of these is a basket. Like, and I actually use this name, reference it. Kind of like how, notice here, fruit, and then it references fruit. So that's actually important. That has to be like the same, like it's an uppercase F here. It has to be uppercase here. Now I'm just going to copy over the rest of it before we go for our break. So that's just the rest of it there. So again, this is this to JSON. So this makes sure that the document, when I want it to be converted to a JSON, essentially we're just going to, ID becomes a string from object ID. And what else changes is that we delete the password hash when we essentially get this. So, because again, we shouldn't have the password hash be returned. That's not good practice. Okay, so we're going to have that. We have made our person model. We're actually going to set up the routes as well. But I think first, let's take a 5-minute break, and then we come back, we'll finish with setting up the routes. And we'll also test it. So we will go through testing these endpoints as well, creating people, logging in, checking, are we getting back what we should be getting? Does creating a basket, is it going to add it to the person, right? So stuff like that. Recording. Okay, so we just added our person model. That is good. We're going to do a commit. I'm actually going to check out the branch part. Okay. We're going to add this. We're going to notice that I make commits quite frequently. Created person model. That's good. Okay. And now what we're going to do is, let's think about the endpoint. So actually the easiest endpoint to first set up, let's do the persons first before we'll do login after. So actually I will just call it people.js. And right, so here we actually do need to install a new library called bcrypt.js. Okay, now that is actually so that we can hash the passwords and also compare passwords that are hashed with what we're sending in when we send our login request. So those functions are required. So we're actually going to first, we're going to import that. And I'm actually just, because this router will look a lot like Basket before we change it, I'm just going to have Basket on the side here to reference, okay? So let's just do that. And there are a few models we need to reference. We actually need to reference all three because, well, think of it this way. When you delete a person, that is actually when you need to delete all the baskets and the fruits that they own. So that is important. I think what I'm also going to do, I'm just going to drop this database because I need to delete, like, these things inside of them are not actually, it's almost like, for instance, when I make this change with the person, that existing basket is not owned by a person, so it's actually not correct. So I'm just going to drop the database. But when I send another request, it'll recreate it with all those models there. So that should be fine. And let me just, okay, so this is going to be, what can I call it? People router. And I'm just going to export here, people router. Okay. So at this point in time, I can actually add that directly to my server here. I can, let's just import it here. People router require people. And then I'm also going to add it here. We'll just put it here, app.use API/people, and then people router there. So there's that. And okay, let's just, so again, I'm just going to copy this bit at least. People router, people/about, first endpoint for people router. Okay, so let's test this. Is this working as expected? Have this running. And let's clear these. Make a new request. Localhost 3001/API people about. So that's going to be, that should hit this endpoint. And I think what's going to happen also, the database will get initialized. If I refresh this, we should see those 3 collections inside of Orchard. Perfect, and we do. So that's good. Let's now do some of these, the rest of these. So, GET requests are pretty straightforward. I will just copy this. Actually, just copy all of that. So, people and bulk people persons list as a JSON. Now, you might find it, like, the thing is, some of these probably will not be used. I cannot imagine a scenario where we might need all the people, right, in this sort of way. But regardless, even if it's not going to be used, it's good just to have that endpoint set up just in case. It is a standard, having a bulk request like this is pretty standard. You can, like, most of these I can just copy directly because they're not that different. People, a specific person. This will actually be used. Okay, person. The return person. Perfect. So we have that. Now, onto the post request. So this is actually going to be, this is where things will change a bit. There's a few things that'll happen. Let me actually have this here. So I'll put a comment down and now we can actually write it. So dot post, and we don't need to send anything in. So we can just have, other than the request body. So let's first get our fields. So we're going to just have name and password. Those are going to be in the request body. And those are the standard fields, the standard information that is sent. We can have some error handling. And I'm actually just going to copy this because, again, I have written this before. It's very straightforward. It's just checking, okay, if name is undefined and if password are undefined, we want to just say, you're missing content. This is an error. It's not good. Okay, so that's all we need to do. But there's one more thing we actually need to check, and this is actually something that we need to enforce in this endpoint. What if someone creates an account with some name and password, and then what if someone else tries to create an account with the same name? So that's an issue, right? So we want to be able to handle duplicates. So we want to check if person already exists, if that name is taken, right? So we can use a function called duplicate count. Well, I will store, I'm basically gonna store the amount of people that we find with this name in duplicate count. Okay. So person, there is a method built in where you can count documents that match a given criteria. So what we're going to look for, and we have to execute it. So this is almost like a query that is run, and it's going to count all cases of documents inside of the person collection where the name equals is essentially this name that we send in, and then it executes that. So if this is working correctly, we will never have a case where duplicate count is greater than 1. Because if it's equal to 1, we will actually send them an error, right? So we'll basically be like, if it is not 0, we should return an error. For 100.send, and I'm going to send an error, be like, okay, oops, name is not available. Okay, so we're going to have that. We're going to check if a person already exists before we try to create them. Okay, so if someone manages to get here, what that means is that they pass the duplicate check. So what we need to do now is this password that you send in, we need to hash that when we store it, because again, the person model that is stored here, oops, this one, it's a password hash. It's not actually going to be the password directly that's stored in the database. So there is that. So let's perform the hash. And for this one, I'm just going to store the result of it in password hash. Here we need to use bcrypt. So it is that bcrypt.js I've imported, but I've named it just bcrypt. And there is a method called hash. Now, the first thing is actually what I want to hash. It's just the password. And then we have something called salt rounds, which is essentially this number here dictates like how many rounds of hashing are occurring. 10 is a good number. Anything really high, it'll actually take too long to hash. So that's not good. 10 is like a good compromise. Now we're going to create the person. So we're going to say person equal new person. It's sort of similar to what we have here, but again, now we actually have the name and the password hash, right? Oops, password hash. Now, again, you know, when you make an object like this, it's the same as doing this, right? But it's just shorthand to do that. Let's update people and return resource because we want to return the result of this. And I think the phone book example that was covered before last week on Monday with login, that explains in detail why we actually need to return the response back to the caller. Okay, so we have response.status 201. So that is a successful creation. And then I will return the result to here. And actually, when we return it, we end up getting we basically we don't have the password hash. We just have the ID and the name. So that's good. Okay, so that's our post endpoint done. Let's work on delete. So delete is actually going to be a more complicated one. Here. Delete is actually where we're going to use all 3 of those collections. So we're going to have people router dot delete the async request response. So here's a question for everyone. What are the things that we want to delete in this people router other than the person themselves? Exactly, we want to delete the basket. So the first thing we're going to do is Yeah, the basket and the fruit. So we're actually going to get the baskets to delete from the ID. So how can we do that? We actually did something very similar. Notice here, we're getting the fruits. We can do something very similar to get the baskets. So we can say basket IDs equal, we're going to await person dot find by ID. So it's almost like we need to find the person, then we get the baskets, and then we map over those baskets, and we're just going to convert the ID to JSON. It is very similar to what we're doing here to grab fruit IDs. We're just getting basket IDs here. Okay. So that's good. We have that. What about now? So now we have basket IDs. Now we need to get the fruits. Get the fruits to delete. So this one is a little bit more complicated because you have to think, so we have an array of basket IDs, but what we need to do now is we need to basically, it's like we need to get each basket ID, we need to get the basket, but the thing is, each basket has fruits, which is another array of fruit IDs. So it's like, it is a bit more complex, but I'll explain it as we go through it. We actually first need to get the baskets. So that's going to be, we're going to use promise.all on the basket IDs. And then, but the thing is, first, like this is actually going to run first. So what it's going to do is, so what this first line of code is doing is this bit here is going to make an array of requests that basically get the basket on each ID, right? So if I have this array of 5 basket IDs, each of that ID is going to be replaced with basket.findById. So it should be a basket, ideally. And then the promise.all ensures that these are all handled by the time this is finished, okay? So we have baskets, but now we need fruits. So what we're going to do, we're going to map over that. Because this is essentially an array of objects. This baskets. It's an array of objects. So what we do is we map over that and we replace each object with a basket.fruit. So essentially what's happening here, so we're taking this array of objects, and remember I'll just do one of them. This is a basket, right? So it has ID, it has name, it has fruits. And what we're doing is we're mapping over each of these and just returning fruits, which is another array with a bunch of IDs in them. So that's actually what's happening there. So this fruits is an array of objects with fruits, and then this in it. Actually, wait. That might be incorrect. Yes, my mistake. My apologies. So so this is a basket, right? When we do basket.fruit, we're actually getting the value associated with this fruits key. So it's actually an array. Like basket.fruit is an array, right? Because basket itself is an object. Fruit is the key. The value of that key fruit, like the value associated with that key, is an array. So what we actually return, this is an array of arrays. And each of these arrays here has the ID of all the fruits associated with that basket, okay? So now when I do this is an array of arrays, but what we need to do is we need to do something, we need to like flatten it. So we just have a single array with all the IDs instead of having an array of arrays. So what we do here is we can just do this, fruits.flat. So this turns it into one array, and then we map over that array and convert the IDs to JSON. So that gives us the fruits to delete. Does anyone have any questions on that, particularly this bit here that we're looking at? So this bit here, like this line. For sure. So what this flat should do is it's going to take this array of arrays. Notice each of these arrays has a bunch of IDs, like 1, 2, 3, and so on, right? These are fruit IDs. It's going to basically, by flatten, it will turn this into a single array. So let's say this is 1, 2, 3, and then the contents of this array is 4, 5, 6, and the contents of this third array is 7, 8, 9. It will turn this into a single array, you know, with like 1, 2, 3, 4, and so on all the way up to 9. So that's what the flat will do. So, but once the flat is done, we have a single array, I believe. Let me just double check. It returns a new array. So it looks like it's returning a copy. And it's interesting. Notice that there's something called recursion depth, which is like how deeply does it want to perform to flatten these arrays. So by default, it looks like it's 1. And we're lucky because this is a depth of 1, which is an array inside of an array. No, we're going to delete the person. That's just going to happen last. So we will do that. It's just going to happen last. We're just getting the baskets from the person. Then we're getting the fruits from the baskets, right? So we get all baskets that this person owns, not just one. And then we get all the fruits from all the baskets. So that's how that's happening. It's like each of these is a basket, could potentially. So basket 1, basket 2, basket 3. Flat turns this into a single array of all the IDs across all the baskets, all the fruit IDs across all the baskets. So that's what happens there. Then we just map over this and we just convert these to strings, these IDs from object IDs to strings. Okay. So that happens there. Now what we do, and let me actually just clear the annotation. Now what we need to do is now we actually just perform the deletions. So here we perform deletions. So we delete the person, we delete the baskets, and we delete the fruit. So we'll do it in that order. So person, find by ID, and delete ID. And you notice like we get everything we need to delete beforehand, so we don't really need to worry about, okay, like I don't lose the person, you know, I don't really need the ID anymore. So that's fine. And then we'll have another promise.all. And then this is, we're going to delete the basket. So basket IDs dot map. So we're deleting all the baskets owned by that person. We use a promise array so we have promise.all. We map over the basket IDs, and each basket we find and delete. And we know that these are baskets owned by the person because we have this bit here, right? That grabs that person and grabs the basket. And it's by virtue of this that we also know that these fruits are also all fruits that are owned by baskets that the person owns. So again, the fruits are also owned through the baskets by that same person. So we delete the baskets. Now let's delete the fruit. It's exactly the same. Fruit IDs dot map. Fruits dot find by ID and delete. And we are done. We just need to send a response. So that is one of the more complicated deletions that we will see. That's basically it. It's because of how many, I get the baskets, I get the fruits, and then I have to delete them all, right? So it's a pretty complicated data flow. First, we delete the dependency so that we can delete itself. Yes. Notice, yeah, it might be better just in case to move the fruits first, then the baskets. then the person, but I think it should be fine. You know, what'll happen, I think what happens internally, it doesn't really matter because the thing is, the basket itself does not have a reference to the person who owns it, and the fruit does not have a reference to the basket. So the order in which these are actually deleted is not important, at least in this case, just because the reference is only from person to basket and from basket to fruit. So we can delete the person first. That's totally fine. Because the basket doesn't have any reference to that. Yeah. You know, actually, the thing is, even if you delete the fruit, I think internally, when you remove that fruit, I think internally MongoDB, like if you remove the fruit first, then the fruits inside the basket, I think it can remove those IDs. Like internally in MongoDB, it will do that. But either way, actually, if just so there aren't issues, it might be best to delete it in this order. Like we first, the highest level deletion, the person, then the baskets, then the fruits. Yeah. Okay, so let's just save this. Added persons router and all endpoints. That is good. So we have that done. Now let's do our login. And then once we're done login, we will change the we'll actually end up changing the basket because a few things will change in the basket that we have to think about. Okay, so I'm just going to copy most of it from our original version because that's not changing. Let's see, we only need one endpoint in this, which is just the post request. Because we're going to use the login. The login is just going to be a post request. You know, you send the data in, and yeah. So login router, we're going to post and async request response. Now we need to get our fields from the request, which is just name and password. And we're going to do request.body. Now we're going to get the user. So we need to actually get the person. There's a match. So we're going to do await. Find one person with the same name. We're going to check if the password is correct. And actually, we need to do a few things. We need to check if the password is correct. We also need to confirm, does this person exist? So there's two things we need to do. So we're going to say password correct. That's going to be like a Boolean that's going to store. Yeah. If it's true, that's fine. It's only if it's false that something is wrong. So this is going to be like, so if the person is null, if this is true, it's false. Like, we're going to use a ternary operator. I could use an if else, but just to save on space. Basically, this check is going to be like, okay, is the person null? What this means is the person does not exist. Then it should be false. Otherwise, if the person does exist, we're going to wait. We're going to do a bcrypt dot compare. And what this is going to do is it's going to compare the password that we send with the hash that exists in the database that we can actually grab from this person. We're going to have password. And remember, like, we only enter this case if the person is not null. So we don't need to worry about like not being able to, that password hash not existing. So I will say person dot password hash. Okay. Now we're going to say this is person check. If not password correct. Now what that means is that if password correct is false, then enter this case because it's a not, right? I will say also this compare returns a Boolean, right? So it's a promise. It's a promise, but of type Boolean. So this will either be true or false. So we have a few cases. We have one case that's automatically false. Person does not exist. We have another case that could be false. Password is wrong. So there's two cases. So here, I'm just gonna return a status 401. That seems to be, from what I could check online, that seemed to be the common response. I'll just say invalid username or password. Now, if you want, you can actually distinguish the errors. You can have a separate error message sent if the person is null. So you can totally do that. That would probably be, it could be a checkup here. If person is null, then you return this user does not exist, right? So there is that. But in my case, I just put those two errors together into one thing there. All right, so now we're going to return user information on success. Response.status200.send person. And that is it. It's just one endpoint on login. So it's pretty straightforward. Does anyone have any questions? Any questions about that? How that was set up? Okay. So we'll add it to the server here. Actually, I need to import it here. Login router / login. And here we'll add it. Login router. We'll add it there as well. Okay, so what we're going to do now make a commit. Added login. Okay, so that's good. So now we've added people. We've added login. What we need to do now is we need to change baskets to accommodate the fact that now a basket is going to be owned by a person. So a few things will change. And actually, what we can do is we can have the fruit referenced here because the fruit does have that concept of it being owned by something, right? It's owned by a basket. So things will change in a predictable way. We can just have it there as a reference. So the first thing we need to do is we actually need to, we need to add the person here, right? Because now we are going to, when we create a basket, we add it to a person. When we delete a basket, we remove it. So most of these endpoints don't change, but actually this one does here. And how this changes is similar to how this fruit router looks. Now notice here, we just have the request body. Notice that the fruit router post actually has the ID of the basket it should belong to. So it looks to me like this also needs an ID, and we can say here, note, the ID required is the ID of the person the basket should belong to, okay? So we're gonna do that. We're gonna have a person ID request.params.id. Now, this is fine. Okay. Here, it looks like we need to get the person. It's getting the basket. So I'm going to actually say here, get the person, person.find.id. You'll notice, like, again, because of that, noticing that pattern of what's changing, you can actually use existing code as a reference to write new code. It speeds up the process quite a bit. Because I know that I just need to rewrite a lot of this stuff here, right? So I get the person, I need to do an error handling check here if the person exists. Just like over here, I was checking if the basket exists because, we cannot create a fruit. We cannot create a fruit without a valid basket. So I'll have response.status400.send. So if there's an error, I'll just say no such person exists to add the basket to. Okay. What else do we need to do? Here we create the fruit, we save it. Okay, add the fruit to the basket and save that. So I'm going to say here, add the basket to the person and save that. So here I will do, so before basket.fruits, now it's person.baskets equals person.baskets.concat, save basket, and then the So here, what's returned when you use like a Mongoose model like this, like what ends up getting returned in this case is actually the document. You can actually even see it here, document. Whereas here, I believe it should say object. Say somewhere here. Maybe not. It's interesting. Perhaps when the response is sent, it gets turned into a JSON. Because I know for a fact, like when we receive this, for instance, it's not underscore ID, it's ID. Maybe that's something to look into later. But notice here, like this save, it returns a basket.save. It returns a document, promise document, right? So that's why I know it's actually underscore ID, not ID. So there is that. Okay, so let's just save the person. And that's it. That's all we need to change in the post request. And notice that we could use that fruit as a reference for what to change. Okay. Now let's change the ID. So here or let's change the delete. So here for deleting a fruit, it says that, yep, the ID is the fruit. And then what we're missing is you should pass the basket ID in the request body. Okay, so here I'll say you should pass the person ID in the request body. Let's get person ID request.body. Here we check if the basket exists. Okay, so here I'm going to check if the person exists. I'm just going to copy this bit up here. It's the same check. But instead of remove, it's going to be, instead of add, it's going to be remove the basket from, right? Okay. Then it looks like we remove the fruits here. This is fine, actually. We delete a basket. We need to, okay. The first thing we'll do, actually, I will remove the basket from the person that it's owned by. Let me see. I don't think the order matters too much. Yeah, I think I'll leave it. We're gonna first just get rid of the fruits. Actually, let's first we're going to remove the basket from the person who owns it. Then we're going to remove because basically if we remove it from the person who owns it, that's fine, it's separate. Then we're going to remove the fruits, or essentially we're going to remove the basket, then we're going to remove the fruits. The order doesn't matter, but actually if there's an issue in the order, then we'll see, because how I did it earlier was a different order. I don't think there should be an issue. Okay, so how do we do this? How do we remove the basket from the person who owns it? Okay. We can do something really similar to what we did up here. So we can say person.baskets.filter ID to JSON. So we're going to check it does not equal basket ID. And that'll basically, this will only be true in all cases where the basket ID is not the same as the ID we're looking at. So this will filter out, it'll filter out when we actually are looking at the correct basket ID. So when we're looking at the one we want to remove. And then I'll do await person dot. Right. Now we're going to remove the basket. So it will just be this one. Actually, we need to remove the fruit first. We cannot remove the basket because unless if we get this beforehand, but actually, so here we're gonna use the basket ID
to basket, right? Find by ID. We're going to use it to grab all the fruits that are owned by that basket. And then we're going to delete them here. So remove the fruits. And then we're going to remove the basket. So we can just have that there. Okay. And that should be good. So that will be the basket endpoints updated. Now we need to test this. So, okay, our lecture is pretty much come to an end, but we will test this. Let's first create a person. Now, what I like to do is I just like to have the endpoints here that I'm using. Basket, fruit, people. There we go. I guess login as well. So let's first create a person. 2001 API people, and it'll be a post request. So remember, a person has to have a name and a password in its post. Yep. So let's do a name. Let's just do instructor, and the password is going to be test. Let's create that. It succeeds, and notice baskets is empty. So if I refresh this, I should see that person in my database. Good, and they don't have any baskets. Perfect. Let's now create a basket. So we need that ID, and actually we will see it. Let's actually first try logging in. So log in, and we will send this request. That should succeed. If I change that password slightly, it'll say invalid username or password. Good. If I try to create the same account, right, with the same name, it should say name not available. Perfect. So that's just to check if some of those things were working. Okay, let's create a basket. So, okay, let's actually first do a login. I just want to get that. Oops, yeah, it was test, not test 1, 2, 3. I want that ID because I need to create a basket. Okay, so let's see. This post request, it does require the ID. So I need to do, oops, there. And let's just call it basket. Actually, let's first see what happens. Let's see, what if I change this to like an F, right? So this is actually, a person does not exist with this ID. So it should say, oh, cannot post. I think it's baskets, yeah. Not post. I do something wrong, API/baskets, API/baskets/ and then the ID. Oh, okay, interesting. I forgot to add that ID there. So this should return an error. It should say no such person exists. Okay, perfect. So it's doing that check, right? If I put EE, and if I send an empty body, it should tell me missing content. Okay, good. And if I have everything, it should create the basket. Okay, good. So I'm going to have basket there, and it should actually update this. So you'll notice here. Perfect. So now notice how we're referencing a basket here. And then if we go to baskets here, that's that particular one. There's no fruits there yet, but there will be soon. Let's now create a fruit. So we'll make a post request to fruit. Just check that. And I need the ID of the basket. So if we actually go here, that'll be the basket ID. The name of the fruit, let's just say it's an apple. Oh, and then sweet is true. Let's make that post. Actually, let's change this to like 1, and it should say no such basket exists. Perfect. If I change that back to 4, it should create that fruit. And now you'll notice inside of baskets that now we have a fruit being referenced, and we have the fruit here. So that's good. Let's just create one more fruit. Mango. Okay, so create a mango, refresh. Perfect. Okay. Let's do that deletion. So let's actually try deleting a basket. Let's see what happens. I just passed the ID. This is the ID of the basket. So I can just do delete, and I can just do baskets. No such person exists. Oh, okay, actually, my bad. I need to pass in the ID of the person as well. So let's go to people, and we're going to copy that. And I believe, if I'm not mistaken, the basket deletion, right, the person has to be in the request body. That's actually a correct error response, because it can't, there is no, like, this is undefined, but actually it would be better if here, if instead of just having this, I had actually put a check that checked for if that was present. So it would be something like, if no person ID, then here it would be like return response.status and so on. That would probably be a bit better. I would have noticed that then. Okay, so here I'm going to have person ID, and then I'm going to, that is the ID of that person, and I'm deleting the only basket that they have. Looks like that succeeds. So the person should now not have a basket. The basket should also be empty, and the fruits should also not exist. Okay, perfect. So it looks like everything is working as intended. So that is good. Right, so that was just to fix that, adding that in. All right, so that is everything. So that's everything for today, in terms of lecture content. I can push this up, but so I will, but the thing is, it's the same example that we have actually sent to you that is available. So it's essentially the same thing. What we have here is this, it's just the orchard example that we have sort of sent to you in that announcement. But I will make sure, I will push this to main. And I'll make sure to merge into main as well. Does anyone have any questions about what we've had today? Either announcements about certification project or any lecture content as well? One thing that might have been a bit confusing actually was the dependencies themselves. So maybe I can talk about that briefly. So we have person, and then the ID, like the baskets, I'll just call them B here. These reference a basket. And then the fruits here reference a fruit. So the idea, one thing that was interesting is that, does the deletion order matter? Now that's a good question, because the thing is, if you delete the basket first, right, then there's a point in time in the database where this ID that's referenced in this here is actually not, like, there's no ID in there's no basket ID that this is correct. It would be interesting actually, like you can do a test if you want, I'm not actually sure how it would handle this. I think like this was a scenario that existed based on the order in which we did it, but it still worked. I have a hunch that what happens is that if we delete the basket first, there's like a period where this is null. Or it just removes it. It's likely that it just removes it on its own. And so then when we actually delete a person, we probably wouldn't need to map over their baskets and delete them manually in that way. If we just delete like yeah. Well, we are mapping over it anyway. Like that's actually what's happening. So yeah, if we like, let's say if we in this person in the person endpoint, like in the person router for deletion, if we delete the basket first, then there will be a point in time where this will just probably be null, or it'll just be removed here. That's possible. You can always confirm that. And let's say here, if we delete the fruit first, there is a point in time where that won't exist. So it might be better practice to just delete it in the order of this goes first. So because then these references are gone, and then this happens, and then this happens, if it's possible. That might be ideal, just to avoid any issues where like this is set to null or something. I think MongoDB can handle that, so you probably don't need to worry when it comes to the order. Yeah, I think MongoDB should be able to handle it because if I recall correctly, the deletion here, it looks like we first deleted fruits and then we deleted basket here. And I'm pretty sure this worked. This will work just fine because that's the same implementation I have in the orchard example, and that was tested quite rigorously, and that worked just fine. So it should be fine either way. But I just wanted to bring this up again because it was a good comment about the dependencies that was brought up. So I thought I would cover it once more. So that is everything for today as far as lecture goes. Let's take a 10-minute break and then we can start our lab.